Here's the first video reviewing the second exam. We start with the first question, naturally, and we're using a combination of the remainder theorem and synthetic division to evaluate this polynomial for x is equal to -2 and x is equal to 2. To use synthetic division, that means that we put the coefficients of the polynomial here on the top row and put the number that we're evaluating right here in this little box. Now, there is no cubic term, and so we have to put a 0 here as a placeholder for the cubic term. So the coefficients are 2, 0, 1, -18, and -9, as they are here. 2, 0x cubed, 1, -18, and -9. And as we proceed with our synthetic division, we drop the 2 straight down, multiply the -2 times the 2, and that gives us -4. The result goes here in the second column, and we add the 0 and the -4, that gives us -4. Then we multiply the -2 times the -4, which gives us a +8. And we add, and we put that here in the third column, and we add that column. 1 and 8 is 9. 1 plus 8 is 9. -2 times 9, then, for the next step, gives us a -18. We put that result under the next coefficient, and we add that column. -18 and -18 is -36. And our last multiplication is -2 times -36, which gives us +72. And -9 and +2 gives us 63. And what ends up here, whatever value ends up here at the end of our synthetic division, is the value of the function at this independent variable value. So the value of the function at -2 is 63. Now for the second one, we do all the same things, except we have +2 here instead of -2. So we drop the 2 down, and 2 times 2, +2 times +2 is 4. Add this column, 0 and 4 is 4. And we multiply the 2 times this value. 2 times 4 is 8. We put the result here. And we add this column. 1 plus 8 is 9. Then we multiply the 2 times the 9. 2 times the 9 is 18. And -18 and 18 is 0. And we multiply the 2 times 0, which naturally gives us 0. And add that last column. -9 and 0 is -9. And that tells us that the value of the function at 2 is -9. It's a pretty straightforward question. That's why I start the test with it, because it's an easy one to get us going and perhaps build our confidence for the rest of the exam. All right, now in number 2, we're asked to construct a polynomial function with the following conditions. There's a 0, there has to be a 0 at -2, -1, 0, and 1. And each of the zeros has to have a corresponding multiplicity as dictated here. They all have to be different. 1 has a multiplicity of 1, 1 will have a multiplicity of 2, another 3, and then a number greater than 3. And we're asked to leave our polynomial in factored form because to multiply it out would be something of a headache. Now, the simplest way to put this together is to put all these in order. X plus 2 corresponds to a 0 of -2. X plus 1 corresponds to a 0 of -1. And then x, just x, corresponds to a 0 of 0. You don't have to put a factor here, x minus 0 or x plus 0. That's not necessary. You just put x, and that tells you there's a 0 at 0. And then the last 0 is 1, so we have a factor here, x minus 1, corresponding to a 0 at x equals 1. And then the multiplicities I put here in the order they were listed: 1, 2, 3, and something greater than 3, which is 4. I could have chosen 5, 6, 7, whatever I wanted, but 4 was just what I chose. And that graph then is sketched here. Now you may notice that there's no scale on the y-axis, and that's because if you graph this in your graphing calculator or online at perhaps Wolfram Alpha, you'll see that it's kind of a wacky graph. It stretches out a long way on the left side, I think, but it's kind of a cumbersome graph to sketch. But that doesn't matter. I don't need that. I don't need the vertical values, the function values, to be accurate. All I'm after here is to see that you understand the effect that the multiplicity has on the graph. So, for instance, the 0 at 0 is raised to the third power, and so that's an odd power greater than 1, and so the graph curves through at that 0, and for the multiplicities of 2 and 4, the graph bounces off. It touches at one point, goes down, or it touches at one point and goes back up. The degree of this polynomial is 4, plus 3 is 7, plus 2 is 9, plus 1 is 10, so it's even. So that means both ends will point up or both will point down. There's nothing here in front of the polynomial to make the leading coefficient negative, and so both ends turn up. This is another polynomial. This is another possibility. And I again have the zeros listed in the same order as they are here, as they are listed, but the multiplicities I put in a different order in order to make the graph fit a scale you might see on your graphing calculator. Again, you don't have to graph on your graphing calculator and reproduce that here. And that's why I don't put a scale on your exam. I won't have a scale on the blank graph. So I hope all of that is understood. Now the third question asks us to list all of the possible rational zeros of this polynomial function. And to do that, we need to identify the p and the q. The p is the constant term, the q is the coefficient of the leading term, the leading coefficient. And all of the possible zeros requires all the factors. We list all the factors of the constant term as the factors of p. Well, what are the factors of 35? 1, 5, 7, and 35. That's all there is. Those are the only ones. But we do have to indicate the plus minus 1, plus minus 5, plus minus 7, plus minus 35, because we could multiply negative 5 times negative 7 and get positive 35, just like we could multiply positive 5 times positive 7 and get positive 35. And then the factors of the leading coefficient, which we designate q, are, since it's prime, just 1 in itself, and we put the plus minus. Then we line up all these factors of p in the numerator of a fraction, and all of these factors of q in the denominator, and we figure out what all the possible combinations are. Well, we could have 1 over 1, and that would be 1, but of course we have plus or minus 1. Or we could have 1 over 7, and that would be 1/7, or plus or minus 1/7. So that takes care of these two pairs of zeros. Then we move on to the 5. 5 over 1 is 5, plus or minus 5. 5 over 7 is 5/7, and that's plus or minus 5/7. And that's all we've got for the 5. Then we move on to the 7. 7 over 1 is 7, so plus or minus 7 is here. But 7 over 7 is 1. Well, we've already got 1, so we don't need to repeat it. So now we move on to the 35. 35 over 1 is 35. Again, we have the plus or minus. And 35 over 7 is 5. Well, we've already got the 5, so we're done. We just have to put the plus or minus for all of these.